Alright, let's see how you did with number 10. Square root of x minus 10 equals the negative of the square root of the quantity x minus 20. The radical sign's already pretty well isolated for us, so we can just go ahead and square each side. When I square negative square root of the quantity x minus 20, I just get x minus 20 because the negative signs hit each other, cancel out. It's just a factor of negative 1 that would multiply with itself. Over here, I just put parentheses around that and the superscript, the exponent 2. Then I go ahead and expand this and I get square root of x squared, which gives me x minus 20 times square root of x plus 100 equals x minus 20. Subtract x from each side, I arrive at minus 20 times the square root of x equals minus 120. Divide each side by minus 20 and I get square root of x equals 6. Square each side, I get x equals 36. I think, but we'll have to check. So I take the original equation up here and I plug in 36 in place of x. So on the left hand side I get square root of 36 minus 10, which is 6 minus 10, which is negative 4. Over here I get the negative of the square root of the quantity 36 minus 20, which is the negative of the square root of 16, which is the negative of 4. They match, it's good. So I have my solution, x equals 36. Our next topic then is equations in quadratic form, whatever that could mean. Well, let's find out what it means. Look at example 4 on page 290. We're given an equation, x to the 4th minus 5x squared minus 36 equals 0. You might say, well, I don't know how to do that. That's got an x to the 4th in it. We haven't solved anything that has more than x squared in it. True. So maybe we can think of this in such a way that it's something we do know how to solve. Notice that x to the 4th is the same as x squared squared. And x squared appears here. There it is in parentheses. So, suppose I just give x squared a simpler name. Suppose I just call it u temporarily. I let u equal x squared, so I can rewrite this equation as u squared minus 5u minus 36 equals 0. It's the same equation up there, but I've just used a different symbol, is all. And when I look at this, I say, oh, that's easy. That's an easy one to solve. I know how to do that. It factors just like that. I get 2 possible roots here. Work through here. And I see, ooh, x squared equals negative 4. That only happens for complex numbers. So I know I'm going to get a complex number out of here. Every once in a while we visit complex numbers. Alright, so it's x equals plus or minus the square root of negative 4. That's plus or minus the square root of positive 4 times the square root of negative 1, using our rules for radicals. Square root of 4 is 2. Square root of negative 1 is I. So I end up with 2 more possible roots here, plus or minus 2i, the complex number 2i. In fact, if you plug positive 3 in here, it works. If you plug negative 3 in here, it also works. If you plug 2i in there, it works. And if you plug negative 2i in there, it also works. So all 4 of those potential roots turn out to be actual roots. Let's look at another one of them. Let me get my eraser. Where's the eraser? I'll be right back. Got it. Let's look at example 5 on page 291. X to the 2/3 minus x to the 1/3 minus 6 equals 0. And you look at that and say like, wow, what is that thing? You know, fractional exponents. Am I supposed to convert it to radical signs? Should I convert these to cube roots and start working? Yeah. You know, I think that would work. Actually, I think you could go that route. But here's an easier way. Notice again, we can take x to the 2/3 and think of it as something squared. We can think of it as x to the 1/3 squared. And we've already got another occurrence of x to the 1/3 in this equation. So you see the pattern developing again. What should we let u equal? Let's let u equal x to the 1/3. Okay? It's the same equation, but I've just used a different symbol. If I go through and solve all this, I get u equals 3, u equals -2. Then I have to substitute back. This says x to the 1/3 equals 3. X to the 1/3 equals -2. So if I cube each side, I figure out that x is equal to 27. If I cube each side over here, I figure out that x is equal to -8. So I have two potential solutions, and in fact, they would both check. Now your textbook goes on to show that if you want to graph this thing on your graphing calculator or in the Desmos program on the internet, well, it shows you that's another way to solve the problem. The graph of the curve looks like this. Kind of a wild looking curve. We haven't seen anything like that so far. This x-intercept here is one of your roots. Of course, the other x-intercept is your other root. So once you get this thing graphed, you can have a pretty good idea of what the answers are. And it will confirm your algebra. Okay, now work out number 16 on page 298.